Welcome back, students. Myself, Sir Sunil, your chemistry teacher. How are you, students? Fine. I hope you all are enjoying the holidays. Okay. And we have started our third units, elements, compounds and mixtures. Okay, students. And today we are going to continue our lesson. Please take out your book and watch this session carefully. Okay, students, yesterday we have completed the electrolysis of water. Today we are going to start the session by the topic thermal decomposition. Okay, students. And before starting our session, I am going to ask you one thing. Did you start to complete the copy work? And did you start to study? 2 units are completed. Okay. And I have given to you the question answers and everything. Okay, students. Start to study. If you have any doubt, you mark and keep, underline and keep, and ask to me directly when class starts. And try to complete your copy work. Yesterday also I told you, complete your copy work. It is good for you. Your workload will be less when class starts. Okay, those who have the copy. Okay, students. Now we are going to start today's portion, thermal decomposition. Okay, the splitting of a substance into simpler substances by the action of heat on it is called thermal decomposition. The splitting up of a substance into simpler substances by the action of heat. The splitting up of a substance by the action of a heat is called thermal decomposition. Decomposition means splitting up of a substance. If it is due to heat, then we can say that that process is thermal decomposition. For example, chalk, that is calcium carbonate. The chemical name of chalk, that is calcium carbonate, which contains calcium, carbon, oxygen. Chalk contains calcium, carbon and oxygen. Its chemical name is calcium carbonate. Okay, CaCO3. Okay, calcium carbonate. On being heated, chalk or calcium carbonate gives calcium oxide. Containing calcium and oxygen, and carbon dioxide containing carbon and oxygen. Okay, students, on heating chalk, you will get calcium oxide and carbon dioxide. Both the products are simpler than calcium carbonate, and so the latter is a compound. Here is the equation. Okay, calcium carbonate or chalk by heating, you are getting the products calcium oxide and carbon dioxide. It is a decomposition reaction. It is splitting up. By heating, calcium carbonate splits and gives back calcium oxide and carbon dioxide. Okay, there are few examples also. Zinc carbonate. By heating zinc carbonate, will get zinc oxide and carbon dioxide as products. Zinc carbonate splits up. It shows the decomposition of zinc carbonate. Another one, sodium hydrogen carbonate. Due to heat, it will decompose as sodium carbonate, carbon dioxide and water vapor. Okay, we will get 3 products here. By the thermal decomposition of sodium hydrogen carbonate, will get sodium carbonate, carbon dioxide and water vapor. Another example is lead nitrate, the decomposition of lead nitrate. By heating lead nitrate, we will get lead oxide, nitrogen dioxide and oxygen. Okay students, these are the few examples of thermal decomposition. Due to heat, some compounds are splitting up. Few examples we have discussed here. Now we are going to discuss compounds are represented by formulae. Compounds are represented by formula. A compound is represented by a formula which shows how many atoms of which element constitute a molecule of the compound. How many atoms of the particular element contains in a compound shows a formula. For example, here we are going to take the familiar compound, that is water, H2O. Okay, H2O. How many atoms of hydrogen contains in it? We know that 2. How many atoms of oxygen? 1. Okay, 2 atoms of hydrogen constitute 1 atom of oxygen. Clear? We will get water. Okay. For example, water is represented by the formula H2O, indicating that 2 atoms of hydrogen and 1 atom of oxygen constitute a molecule of water. You can derive similar information from the formulae of the following compounds. Okay. Following compound here, one table is given. It's very important table. Why? Because in the examination we are getting one part of questions like that. Write the chemical formula of the following. You please mark it as important. Okay, mark this table as important. Okay, and underline and study the chemical formulae of the compounds. Okay, we can discuss this. First one, carbon dioxide, CO2. Okay, carbon dioxide means CO2. The chemical formula of carbon dioxide is CO2. Sulfur dioxide, SO2. Nitrogen dioxide, NO2. Ammonia, NH3. Hydrochloric acid, what it is? HCl. Sulfuric acid, what it is? H2SO4. Nitric acid, HNO3. Sodium hydroxide, NaOH. Sodium carbonate, Na2CO3. Sodium hydrogen carbonate, NaHCO3. Okay students. Now again, calcium carbonate, that means chalk, CaCO3. Lead nitrate, PbNO32. Ammonium chloride, NH4Cl. Ammonium sulfate, NH4,2SO4. Glucose, C2H12O6. Sucrose, cane sugar, C12H22O11. Okay. By reading like this, you have to learn it by heart. It rhythmically, you have to read the chemical formula and learn it. You won't forget. Okay. What rhythm should be there to learn the chemical formula of the compounds. 1 or 2 or 5 or 10 times, if you are reading like this, you won't forget it. Automatically in your mind the chemical formula will come. Okay, you don't worry. Okay. Now we are going to discuss about important characteristics of a compound. Important characteristics of a compound. You should remember some important characteristics of a compound from these points. Okay. First one, a compound can be split into its constituent elements only by a chemical means and not by a physical means like filtration, sublimation, distillation. Compounds can be split by the chemical method. By the chemical method, compounds can be split. It cannot be split by physical method like filtration, sublimation and distillation. For example, water cannot be split into hydrogen and oxygen by any of the physical method like filtration, sublimation and all. Okay. But it can be split by chemical means like electrolysis. Yesterday we have discussed electrolysis process. By the electrolysis process, water can be split as hydrogen and oxygen. Hydrogen can also be obtained from water by the chemical action of an active metal like sodium on water. Okay, by sodium on water. Okay, students, sodium plus water gives sodium hydroxide plus hydrogen. By acting sodium with water, we will get a sodium hydroxide and a hydrogen. Similarly, hydrogen can be obtained from an acid like hydrochloric and sulfuric acid, okay, by the action of a metal like magnesium, zinc or iron on the acid. Okay, students, here we can see some important examples or chemical equations. Okay, students, it is very important for your chemical equations and all. You are in 8th class. Okay, go through the chemical equations and chemical formula. Okay, and learn it and keep. 9th class, you are going to 9th class. It's very useful. Okay, keep in your mind. Clear? Here it is magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Read it. Magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. Okay, students. Now, second property. The properties of a compound are entirely different from those of constituent elements. For example, hydrogen reacts with oxygen to form water. We know that hydrogen is a gas and oxygen also a gas, but we are getting H2O, that is a liquid. By combining two gases, we are getting a compound water, that is liquid. Okay, students, this water neither combustible nor supporter of combustion. Okay, you can also compare the properties of carbon dioxide with those of its constituent elements carbon and oxygen. In case of carbon and oxygen also same way only. Carbon is maybe solid, oxygen is a gas. By combining these both solid and gas, we are getting a gas compound, gaseous compound, that is carbon dioxide. Again, the bright yellow compound mercurous iodide is a product of two constituent elements, mercury and iodine. Mercury is a silver white liquid metal and iodine a violet black solid, and we are getting, clear, a bright yellow compound mercurous iodide by mixing up of mercury, clear, and iodine. We are getting a bright yellow compound mercurous iodide. Okay, students, the constituent elements of copper second sulfate pentahydrate, CuSO4.5H2O. Underline and keep, it's very important chemical formula. Okay, it's a blue solid. Copper second sulfate pentahydrate. Are the red metal copper, yellow solid sulfur and colorless gases hydrogen and oxygen. Okay. Now next one, elements combines in a fixed proportion of atoms to form a compound. For example, two atoms of hydrogen combines with one atom of oxygen to form water, clear, to form one molecule of water, and the atomic ratio of hydrogen to oxygen in any sample of water will be 2:1. Thus, 10 billion hydrogen atoms will require 5 billion oxygen atoms to form 5 billion molecules of water. There is a particular ratio for the formation of water. The atomic ratios of elements in some compounds are given in the table 3.1. Clear? In 3.1, some atomic ratio is given here. Water, the formation of water, the ratio is 2:1. H2O, the compound is formed. C:O, carbon dioxide, the formation of carbon dioxide, the ratio is 1:2. CO2 is formed. Nitrogen dioxide, 1:2, the ratio, NO2 is formed. Sulfur dioxide, the elements are S and O, sulfur and oxygen. The ratio is 1:2, that is SO2. Hydrogen chloride, hydrogen and chlorine, 1:1, HCl is formed. Sulfuric acid, hydrogen, sulfur and oxygen, 2:1:4, H2SO4 is formed, that is sulfuric acid. Nitric acid, hydrogen, nitrogen, oxygen, these are the constituent elements. The ratio is 1:1:3, HNO3 is formed. Next one, calcium carbonate, Ca, C and O, calcium, carbon and oxygen. The ratio is 1:1:3, the compound formed, that is calcium carbonate, equation is CaCO3. Okay students, another property is a compound contains the constituent elements in a fixed proportion. A fixed proportion of mass. A compound contains the constituent elements in a fixed proportion of mass. For example, by mass, water contains 1 part of hydrogen and 8 parts of oxygen. So, the mass ratio of H to O in water is 1:8. Can you guess how many grams of water will be formed by 1 gram of hydrogen and 8 gram of oxygen? The law of conservation of mass gives you the answer. It is 9 gram. 1 gram plus 8 gram, that gives 9 gram of water. The law of conservation means as matter is neither created nor destroyed. Also, the mass ratio of carbon and oxygen in CO2 is 3:8. This suggests that every 11 gram of carbon dioxide will contain 3 gram of carbon and 8 gram of oxygen. Okay students, 3 gram of carbon and 8 gram of oxygen in carbon dioxide means the ratio is 3:8, the formation of carbon dioxide. Okay. Now our next topic is mixture. Okay students, it's a time to wind up our section. If you have any doubt today's portion, you can ask the doubts to me directly in the class. Okay, you please read the chapter 2 or 3 times and learn the question answers from unit 1st and 2nd. Please revise and keep. Okay students, today I am going to wind up this session. Thank you and have a nice day.